Alright, my name is Chris Leginski, and I'm on the yellow team, and our system is the spray booth pressure system. So to outline my presentation, first I'm going to go over some background information of our system, along with some general information, and then our results from previous experiments, steady-state operating curves, step response results, frequency response results, and then the Bode chart, experimental, and the modeling results, and a comparison of those, and then conclusions. So this is the block diagram of our system. The input is power percent, or percent power. The output is pressure, and centimeters of H2O. And our output ranged from 2 to 17 centimeters of H2O. And throughout all of our experiments, both dampers were open. This is our steady-state operating curve between 2 and 18 centimeters of H2O. This purple line here, the line of best fit, had the slope of 0.53. These are some step response results for gain. These black lines represent percent error. So there wasn't a whole lot of percent error as far as gain is concerned. For the dead time, there was a lot of error, especially in the mid to lower ranges. And the time constant, again, pretty good amount of error all around. This is just an example of a step response experiment that was run between 2 and 7 centimeters of water. And all the important values, such as gain and everything, seen in that table up there. These are our frequency response results. The equations for the amplitude ratio and phase angle are seen over there. This graph in the bottom left is an example of a frequency response graph. And there you see where the delta M, delta C were all derived from. On the right is a experiment that we ran at a frequency of 0.3 hertz. And this table shows the actual AR and phase angle that were calculated from this. Basically, I just calculated it twice, between here and here, and here and here, and averaged them to get those. This is a experimental Bode plot that was found between the pressure range of 12 to 17 centimeters of water. This table just shows where all these data points are coming from as far as frequency versus AR. The frequency in this case went between 0.1 and 1.5, the AR between 0.8 and 0.3. This is the same thing with a different output range of 7 and 12 centimeters of H2O. And again, all the data points are found here. That's what makes up the graph. This is a frequency versus phase angle Bode experimental plot. This was between a pressure range of 12 and 17 centimeters of H2O. And you see the frequency versus phase angle crosses 180, or negative 180 about right here, which gives us our ultimate frequency, about 1.4 hertz. These are the modeling results for the Bode plot between the pressure ranges of 12 and 17. This red line was fit to match the data points by these parameters. This is just a graphical comparison of what I just showed you in the last couple of slides. These are the experimental frequency versus PA, frequency versus AR. This is the modeling, frequency versus AR, frequency versus PA. Same data points. The only difference is this line is just a little bit different. And these are the data. This is the data from the slides I just showed you, previous slide. The experimental results and the modeling results. If you compare the gain, 0.8 to 0.1, it's fairly close. The dead time, 0.3 to 0.4, which is also very close. And the time constant went from 0.2 to 0.4. And this was all within the output range of 12 to 17. And just to sum up the previous results from our experiments, from the steady state operating curve, we have 0.53 as our average slope. And from the step response results, our gain averaged from 0.35 to 0.62, dead time 0.04 to 0.2 seconds, time constant 0.12 to 0.23 seconds. That's it.